Hi, welcome to ADM 320. We're going to talk about binomial distribution, finding probabilities using Excel 2010. Binomial distribution, sometimes it's appropriate to summarize groups of observations into two possible outcomes. Everything can kind of be grouped into two possible outcomes. Even if you had a bunch of colors of shirts that people wore, you could still say you could group them into two outcomes. The group that wore red, and of course the group that did not wear red. In our example here, we have a proportion of individuals in a random sample who supports one of two political candidates. In this case, the count of X count of voters who support the candidate is divided by the total number of the group. That gives us the proportion that support the candidate that we're interested in. So we all know the proportion count divided by the total. There's certain properties that make it binomial distribution. You have to fit these conditions so that you can define binomial, not sum or some of the other discrete distributions. In this case, obviously the random variable has to be discrete. It has to be something that's finite, countable whole numbers that can describe the discrete variables. In this case, the first condition in binomial would be the each observation has to be independent, has no influence on the other. Each observation represents either one of two outcomes, either a success, which is what we're interested in, or a failure. So either you're interested in our candidate, and you would vote for them, or not. Either you're wearing a red shirt, or not. And then the probability of success, P, is the same for each outcome. In other words, it doesn't matter what the last person did, you're going to do. That probability of success is fixed and independent and stays constant. And I just always add this in. Remember, X is the number of successes in your fixed number of observations, N. So if these conditions are met, then X, the random variable, has a binomial distribution, which you'll often see noted as binomial with the two pieces that you always need to know to do binomial. You need to know the fixed number of observations and what's the probability of success. If you know those two things, then you can always answer the questions they ask you about binomial. But these are the two characteristics that are very important in binomial. So how do we do it with Excel? Well, using Excel 2010, you'll notice that we use a binomial dot distribution function. If you're not using Excel 2010, you'll notice you don't need the dot. The dots only came into play in these functions that you see in Excel when they went to 2010. But the good news is they do know that not everyone has 2010, and they made sure that the function binomial DIST without the dot can be used if you're like in Excel 2007 or some previous Excel, even 2000. So what are these parts to the function? Well, you'll see the binomial distribution has 4 inputs it always needs to know to be able to calculate the probability. So the first one is the X. What is the number of successes that fit the condition of the problem? P is the probability of success. Then you need N, the fixed number of trials. And then you need to explain whether it's going to be a true or false as the cumulative input. And so the question often is asked, when do I use false? When do I use true? Well, if you're only interested in the probability of exactly X, exactly 4, exactly 9, exactly 100, then you're going to use false, because you don't want to accumulate all the probabilities for all the random variable possibilities up to a number. You only want it exactly at that number. So you'll see that it would be false. If you want to do a cumulative probability, then you would use true in that last input. There's also obviously other characteristics that we can find in binomials. We can find, these are parameters, mean, that's mu. And then we can find the variance, which is sigma squared. And then we can find, here's the mu, which is n times p. The number of fixed trials times probability of success will always give you the mean of a binomial distribution. The variance is sigma squared. And you'll see you have the fixed number of trials times the probability of success times what really is the probability of failure, which is 1 minus p. Obviously, there's only 2 outcomes, so if the probability of success was 0.6, then very obviously the probability of failure would be 0.4. And that would be how you calculate the variance. And then you have the standard deviation, which we know the relationship between standard deviation and variance. If you have the variance and you want the standard deviation, you take the square root of the variance. So you can see here that it's just a sigma, and sigma is equal to the square root of the fixed number of trials times the probability of success times the probability of failure. So So those are the three parameters that we can calculate on a binomial. So now we want to actually do some in Excel. So what we want to do is we want to work with a problem. So here's a problem that we have. We have a university found that 20% of its students withdraw without completing the introductory statistics course. I just made up this problem. Assume 12 students are registered in the course. And then they have several questions. I think there's 5 parts to this one. Compute the probability that 2 or fewer will withdraw is the first question they ask. Well, I find whenever you're doing a binomial distribution, it's always great to set up the whole probability distribution. If you recall, probability distribution is the all the possible outcomes of x and their corresponding probabilities for each of those values. And in binomials, we can have it go from anywhere from 0, in this case up to the fixed number of trials, which is our problem is 12. So if you want to set this up and have Excel do all the work, you need to have a couple inputs. You need to know the fixed number of trials, and you need to know the probability of success. Remember, those are the 2 characteristics that we need to work within binomial distribution. In this problem, the fixed number of trials is 12. The probability of success is 0.2, 20%. Because we're interested in students withdrawing, and we're knowing that the probability of success, which I know success sounds odd because withdrawing doesn't sound like success. But remember, the success is what you're interested in, and we're interested in students withdrawing. So, of course, the probability of that event happening is 20%. And that's why the probability of success, P, is 0.2. And the fixed number of trials, how many total? It's out of 12. So now we're going to set up the probability distribution. We need a couple things. We need to know all the possible outcomes, each individual x values that x could be for this problem, and the probability of x. So here, you know, we can start at 0 students. We could have, out of the 12 students, 0 students could withdraw. We could have 1, we could have 2. And the nice thing about Excel is if you highlight a string of data that has a pattern and you double click, it'll and pull it down, it'll actually continue a pattern for you. So since we were going by ones, it just continued them down until we have 0 through 12, each individually in a cell. Those are all the possible values of x, our random variable. We could have 0 students withdraw, we could have 1, we could have 2, all the way up to all 12 withdrawing. The probabilities are different for each one, but then those are the possible outcomes for x. So let's just find it for the first one, because I find if we create this probability distribution first, these questions over here become a little easier to answer. So what's the probability of exactly 0 students withdrawing? Well, this is a binomial problem. This x variable, discrete random variable, does follow a binomial distribution because I do have a fixed number of trials, 12. I only have 2 possible outcomes: a student withdraws or does not withdraw. I have a probability of success, which is constant, at 20%. The trials are independent. One student withdrawing has no effect on another student withdrawing. And then X does stand for the number of students withdrawing in this case. So if I'm going to do this, I'm going to do a binomial. So you'll see I'll put an equal sign in, B-I-N. And usually when you start typing in Excel, what's nice is if you start the words of the function you want to have, they'll narrow down which ones you might want, and then you can just double click on the one you want. Now it does remind us right here what the order are of the inputs, but some students may find that still not helpful. So if you insert function key, it'll actually open a box to remind you of the order that you need them in. That way you don't have to worry about exactly putting them in order. That obviously will screw up the answer and obviously cause problems in our solutions if we did that. So the number of successes, that's what the n_s is. What's the number of successes? Well, here I want to do cell references. Because I could put 0 in here. Yeah, you could hard code this as all the numbers, but if I'm going to copy down this formula, once I get it right for the first one, then I need to hard code where I need to hard code the references. So in this case, the number of successes will always be to the left. So I'm just going to say, hey, you go to A4 for that, and I'm going to hit enter. And then you can see that it's going to go to A4. And since I don't have $signs on it, if I copy that down 1, it'll change that to A5. If I copy it down 2, it'll change to A6. And that's what I want it to do. I want it to always look to the left to look at the number of successes. Then we have the fixed number of trials. Well, that's a fixed number. That doesn't change. So I want to highlight that cell, which is B1. But you'll notice here that's not hard-coded. So if I was to copy this formula, would find that it actually would keep changing, and I don't want it to change. So I'm going to highlight the B1, and I'm going to hit the F4 function, and you'll see that it puts a $ in front of the B and a $ in front of the 1. And I call that hard coding, because now when I copy this formula, that will always stay as $B, $1, which is correct, since D is what the fixed number of trials is. It's 12. Change unless I change the number in that cell. The next input it wants is the probability of success. The probability of success is also fixed for this problem in sitting in B2. So I'm going to click on this icon here that says go show me where it's at. I'm going to click on B3 or B2. I'm going to highlight B2 and I'm going to hard code it because I don't want that to change either when I copy this formula. So I'll hit an enter. And then the last question is, we talked about that. It's either 0 or 1. I prefer true or false because it is. Do I want it to accumulate all the probabilities up to this point? And the fact is I don't. I want it to find exactly the probability of 0 students, or 1 student, or 2 students when I copy this. So I want to put a false in here and hit enter. And the nice thing is sometimes your calculator or your Excel will give you tons of decimals. And you can see here if I change this decimal format, always go to a number because I think it's more helpful in general. And then typically you'll find that if a probability can be calculated with 3 decimals, I'm going to show it as 3 decimals. Now some of the ones down here become very small, but look like scientific. But we'll change it so that indeed does show it all the way out, so we can actually see it as a decimal format, which is what we work with in every day. So now if I have this formula correct, I can now copy this down. I'm going to go to the lower right hand corner. I'm going to hold down my mouse and I'm just going to copy down until I hit the last value that I have, which is x of 12. And it stays with the 3 decimals because it's copying everything down. And you can see for a lot of these I can calculate within 3. But down here I can't. It looks like the probability of that event is so small that it actually doesn't show up anything in the first 3 decimals. So up here in our formatting area, I can actually increase the number of decimals. And as I increase, you start seeing that some of these actually have values. I just have to figure out. And if you only go out until you hit a number, that will what you're going to show. Decide that you should show something. You shouldn't show it 0 because it's very rarely ever actually 0. Probabilities are not 0 unless it's an impossible event. They can be really, really small, but they're not going to be 0. So now you see I created the probability distribution. A probability distribution is a table that contains all the possible values of x and the corresponding probabilities. And I've created it for this problem because now answering these questions over here on the right will become much easier because I have the individual probabilities. So if you can see here, it says compute the probability that 2 or fewer will withdraw. Well, 2 or fewer students. So I have to look over here to see what possible values of x will fit the condition of 2 and fewer. And you can see here that 2 fits that condition. 2 students withdrawing, 1 student withdrawing, 0 students withdrawing. All 3 of these x values fit the condition of our part A problem. So if I want to find the probability of that event, I actually have to add those up. Let's label our answer, how important it is to label your answers, and then let's actually show that. So if you want to add up cells, you know you do an equal sign, and then you go show it the cells you want to add up. And you can see here, this one, to this one, to this one. It's not the only way to show a sum, but it indeed does work. And most of us probably know that. And then I'm just going to label these answers. Some highlighting so you can see my answers. So the probability that 2 or fewer withdraw from the statistics course is about just under 56%, divided by 8. Now, interesting enough, we did that by adding them together. And you can add them together many ways. You can do a sum feature here instead. You don't have to do the individual adding, as long as you show what cell to start with and what cell to end at. All of them will do the same effect of adding up the 3 cells. But some of you are thinking, hey, I can use that cumulative probability. Remember, we put in false because we didn't want to accumulate the probabilities in this column. But I can create a new column called a cumulative probability, that x is less than or equal to the x value that we have. So let me create that so we can see how that would also do the same thing. And in this case, I'm going to use the same formula that's here, but instead of false, I'm going to put in true. So I'm going to put in equals, binomial, dot distribution, double click it, open up my function by clicking this little function icon right next to it. My fixed number of trials is still sitting in A4 for that one, or my number of successes is still sitting in A4 for that one. My number of fixed trials is still up above the N. And I still want to hard code that. I don't want to change that. Let's get B1 in there. Let's hard code it with an F4 and hit enter. And then the probability of success is still up here in B2, but I want to hard code it so that it does not change when I copy it down. And now the cumulative. We did not want to accumulate when we were doing the B column. When we were doing the B column, we wanted it to do exactly that value. Notice I renamed this new column because I do want to accumulate it. So here I'm going to actually put in true and hit enter. And when I do, you'll notice that for the first possible value of x, your probability of exactly 0 is the same as your cumulative because there's no possible values below that. But as I copy this formula down, you'll notice that what it's doing is it's summing the probability in the column to the left plus all the probabilities before it. And so therefore that's doing the same math for me as if we had done it ourselves. It's accumulating the probability of x of 1 or less than 1. So less than or equal, and that's why I'm using the symbol here. And if you get to the probability of x of 2 or less than or equal to 2, which is what we just did over here in this part A, you'll notice that when we used a true in there, we exactly got the cumulative probability, which is what we needed for this problem. We needed the probability that x was 2 or 1 or 0, and we needed to add those up. And that's what the true function will do. It'll give you the probability of that result or less than that result. And add them up for you. So that's another way you can do it. Instead of doing the sum like we had done before, if you created this column, just do an equals right over to where you want it. Or you could actually put the formula right here in the cell F4 that we're doing, and just do the formula that you want based off the fact that you want true in the end and not a false. Many possibilities of how to get there, but they all give us the same answer. So let's look at part B. And now that we understand a little better all the different ways we can get results, let's see which is the easiest way to get the result for this. So part B says, compute the probability that exactly 4 will control. Well, I know what exactly doesn't include any other possible outcomes but the number that we've been given, and we've been given an x of 4. So I know the cumulative probability is not going to be helpful in this. In fact, all I need is the actual probability for x of 4, and you'll notice we already have it here sitting here in P8. So the first thing I could do is just next to where I labeled the answer, I put in equals, and then I go over and click on the cell that already has the answer. Exactly 4 is right here, and that would give me the answer to the problem. If I had not created the table, then I would need to go ahead and use the results that I had used here, which would be the binomial distribution function of a number of successes of 4 with an n of 12 with a probability of success of 0.2 and with a false because I don't want to accumulate the probability. I just wanted it exactly 4. Only one possible x value, nothing else. That's about 13.3%. We'll leave it as 3 decimal answers. If you always can, in most cases, leave it as 3 decimal unless the number's really, really small and you need to go out more. So then the answer is part B. How about part C? Part C says compute the probability that more than 3 will withdraw. Well, more than 3, if we think about it, here's all the possible values of x. More than 3, well, that would start at 4, and that would be actually from x of 4 all the way through x of 12. So I would need to add up all the probabilities from the x of 4 all the way through the x of 12 that I've already created in my table, which we know we can do as a sum feature. Label it. Say equals a sum, and then I could just have it go add up the appropriate cells. Remember, we said x more than 3 does not include the 3. It would include the 4. So I need this guy all the way to this guy. And since I'm using the sum function, which you probably have used in a previous thing, let's try it again, since I'm typing over something that I didn't mean to. We have the sum from here all the way up to here. And so it actually did that for us. It says I'm going to sum what you have already calculated individually, each of those. And I'll go from here, the point 1 through 3, all the way up to this, the really, really small probability. I actually didn't count it, so they're in front of it. And it says that's about 20.5%. So it's about 0.205 probability that more than 3 will withdraw from this course, based off of the fixed number of trials we were given and the probability of success that we're using. You could also have done a complement rule. For some of you, you know very well that the probabilities for this whole column has to add up to 1. If we summed all these up here, this would have to equal 1. Obviously, the cumulative proves that to us when we accumulated the probabilities. So I could use the complement rule, which means the probability of 1 minus the probability of not that event. So I could have done 1 minus the cumulative of x of 3. So you can see I've done this instead. And lo and behold, don't be surprised, it's the same answer. Both get me the same answer. You don't have to do it both ways. You just have to realize that the probabilities for this column have to add up to 1. If I want it from 4 onward, I could just as easily take the 1 and subtract the sum of these that I don't want, which was this number right here. It's a cumulative probability of x of 3 or less was 0.79. Rounds to 5. 1 minus that is the same answer as adding all numbers. I'll take that off. That's just a little extra information. We want to continue through our problems. So now I got part D. And now we're getting into more the parameters that you can calculate for a binomial distribution. Remember, you can calculate a mu, which is a population mean. You can calculate a population variance, and you can calculate a population standard deviation. And those formulas I had shown you earlier. So let's see which one this is asking about. Part D says compute the expected number of withdrawals from the course. That's the expected number of students. And the expected value or expected number is the same wording as someone asking for the mean. That's something you want to get used to right away. In statistics, the word expected value is the same as the population mean. So in this case, that's a formula. There's not a lot of work I'm going to use on the right-hand side at all because that's formula-based. And the formula, basically, if you remember back on our Excel, was going to be equal to the n times the p, which I actually have to throw values in for that. And we actually have already created 2 cells for B1 and 2. So I'm going to say equals, and I'm going to go point to the things I want it to do. I want it to take this number, B1, and I want it to multiply it by B2. And you can see that the expected number of students that I expect to withdraw in this course that has only 12 students registered would be about 2.4. Obviously, it won't be 2.4 because you can't have 0.4 of a person. But on average, if I ran the same course every semester with 12 students in it for a number of semesters, the average number of students would come back around 2.4. Obviously, some would be 0, and some would be 1, and some would be some other number. But if I average those numbers together over the last 5 semesters, I would expect it to come out around 2.4 numbers withdrawn. And that's what the expected number is, which is the mean of the binomial distribution that we're working with. So now we go to the last problem, which is part E. And part E says compute the standard deviation and the variance of the number of students who withdraw from the course. Well, we know there's 2 parts to that. We know we have to do one at a time. And if you remember correctly, the variance back on the PowerPoint that we had gone over before we started the Excel portion to this video, so the variance is equal to n, the number of times the probability of success times the probability of failure. So all I need to do is go equals. I'm going to find my
apply to the probability of failure. But I don't actually have created a summary for that. Well, I use the parentheses and actually do 1 minus the probability of success, because we know the probability of success is 0.2. That would imply the probability of failure is 0.8. Let me get this shifted over here. You can see, if I had not labeled the edge, so this is the variance. So it's good to label your answers. And then we'll have the standard deviation. Remember, the standard deviation is the square root of the variance. So though I could start the formula over and use the square root option of n times p times 1 minus p, since I've already calculated the variance, I could just as easily put equals. And the way to do a square root is to use the equals, SQRT, that tells Excel that you want a square root of something. In this case, I want the square root of what's sitting in F16, because that's where I already spent the time putting in the variance. So the standard deviation is the square root of the 1.92, and Excel does that for me and tells me that's around 1.39. I don't like that many decimal places, because that just doesn't make any sense, so we'll just narrow it down a little bit. So that would be the variance and the standard deviation of the number of students who will withdraw from the course. So how much variation do I expect in my number from the mean? So the average variations is about 1.4 students. So it will average 2.4 students based off Part D, but obviously we'll see some lows and highs on that over the number of times that I run this 12-student course. So that would end our binary distribution video. Please go back and replay parts that you need to see again, or pause again and go through, but hopefully you've actually created this at the same time that we're doing it together, because that'll get you more familiar with the process. Just sat and did that. I should have done it this way. It took me a little longer. Yeah, it doesn't have one thing. It didn't work.